Today, in this video, I'll be taking you through Grafana, a powerful open source platform that's changing the way we approach observability and monitoring. We will start with an overview of observability, key components of observability, and challenges faced in the field of observability. And later, we will walk through Grafana's open and composable observability stack, which helps solve many of the challenges in the field of observability by bringing metrics, logs, and traces into a single unified view. And finally, I'll showcase a demo of Grafana in action, highlighting its dashboard and workflows can streamline monitoring and troubleshooting for the modern applications. So observability by definition is the ability to understand a system's internal state. So it can be done based on the data it produces by enabling effective monitoring, troubleshooting, and performance optimization. So some of the major challenges which we face in the field of observability are complex infrastructure, data volume, data silos, and key metrics. So benefits of implementing observability is to get faster troubleshooting mechanisms, enhanced productivity, less alert fatigue, better user experience, and obviously proactively identify issues by improving and thereby improving mean time to resolution. So in short, it enhances overall reliability too. So key components of observability are metrics, logs, and traces. Metrics are nothing but the data points from infrastructure and applications. Logs are the record of what happens across an application ecosystem. Traces is an addition to logs or a deep dive into logging, where it will get us the visibility of actual code steps. Yeah, coming to Grafana's open and composable observability stack, this brings together metrics, logs, and traces, the key component of observability in a unified platform. So this allows full visibility across systems. It is built on open standards like Prometheus, OpenTelemetry, which ensures flexibility and avoids vendor locking. The stack includes customizable, ready-to-use dashboards. Let's dive into the demonstration of Grafana. So if you see in this diagram, we are using a tracing app which is deployed in Kubernetes cluster, which sends traces to Grafana Alloy, which is also deployed in Kubernetes cluster. And from that Alloy, it will transfer the traces to Cloud Alloy, and internally it will connect to the Mimir and Tempo service of Grafana Cloud, which will help in getting the metrics and traces to Grafana Cloud. And finally, we can visualize and explore more about traces and metrics in Grafana Cloud. For this example, I'll be making use of my free trial account, which I created in Grafana Cloud. So let me please switch into that. Yes, if you see here, I've already logged into the free trial account, and it's a trial plan. After logging in, go to connections, click on OpenTelemetry. Here we have an option to create a new token. So this token will be used to connect the Grafana Cloud instance to the locally deployed Grafana. Let me give a name, sample monitoring stack token. Let me note this one down in my notepad for future reference. Yeah, so there are some scopes already defined here. So by default, it is having alloy data right, and it will be having some subset like metrics, logs, traces, right permissions. Okay, so let me just quickly create this token. Okay, I have this token now with me, and I'll copy this token into my notepad. Yeah. Now, if you scroll down, we will be having the config, the alloy config. So now our task is to copy this configuration file and save it as alloy config. Let me open terminal. Okay, so let me take a copy of this. Oops. Sorry for that. Let me just quickly take a backup of my existing alloy config, which I have already done. Okay. Yes, I'm creating a file called config.alloy. Inside this, I'll paste the content which I got from the cloud instance. Here, yeah. So if you see, we'll be having the password, the API token which is generated here. Once that is done, let me save this file and let's start deploying Alloy in the cluster. For this, I'll be creating a new namespace. Create. Okay, I'll give it this monitoring stack. Yeah. Now, since we have the Alloy config here in this file config.alloy, we will be creating a config map from the config file which we already have. So it will create config map. I'll give it as alloy-config. Then namespace is monitoring stack. I'm reading it from file. It's config.alloy. It should map as config.alloy. Create config map everything here. Okay, so config map is created. Let's just quickly verified config map. Sorry for the typos. Yeah. So that's been created. Now let's create help chart, or let's deploy Alloy. For that we need a help chart. So let's go here, Grafana Alloy help chart. I think this should give, yeah. So if you see, the Grafana Alloy help chart is coming as part of the Grafana repository. So let me just copy this. Let me add Grafana repo. It's verified, it's being added. Let me update the repo. That's now updated. So to install Grafana Alloy, it's just a matter of running the helm install command using the release name and helm chart. So now let's start deploying Alloy in our namespace. So this is the namespace, and we have our custom values file, Alloy-values. We just quickly check the helm repo. We have the Grafana repos. Now let's go back to the documentation. So it's Grafana Alloy. Okay. Helm install Alloy Grafana / Alloy -n namespace is monitoring stack. Okay, I'll have debug option also. Let me add file, the custom values file, which is Alloy. Alloy values file. Okay, so as it says, Grafana Alloy has been installed. Let's do helm ls -n. Okay, kubectl get pods -n. Right, so we can see Alloy is up and running. Let's just quickly check the logs to see if there are any errors. Yeah, so it looks good. Now we have to install a demo app. I already have a manifest file for a demo app with me. So let me just VI. Okay, so namespace needs to be updated. So this I have updated the namespace to match my previous deployment. So let me just correct it. Done. Yeah, so app name will be XKS's client tracing. Point value just fine. Yeah. Okay, and another thing to be noted here is the deployment value file. So here we have an endpoint. So this application needs to connect to Alloy. So to get that, what we have to do is need to get services, monitoring So this is a service which is in monitoring stack namespace. So let me open the demo app again. If I go to value here, so it should be service name dot namespace name, which is monitoring stack SPC cluster. So this should hopefully work. So let's save this and do a kubectl apply. Okay, so it's been created. Let's quickly check the pods. Oops. Monitoring stack. Yeah, we can see the application is running. Application pod is up and running. Let's quickly check the logs again. Kubectl logs. Okay, so it's running complete. So this is an expected output. Let's go back to the cloud instance. So after logging into the free trial of Grafana Cloud, if I go to the connections here, I have the open telemetry connection. So this part we have already done. We have deployed the config map. Now, if we scroll down, there's an option to add the service name. So here I'll be adding the service name, which is shop backend. So this is the root service for our application. Since I already have the token generated, let me update it here. Yeah. And if I scroll down, there's an option to test connection. And it says the traces are being ingested properly. Now let's go to the application observability part. Okay, give it some time. It will take, yeah, so it's already in. I have set the metrics for last 12 hours because I have deployed this application way back. So I can see one error here, which is mismatch. So since I'm using the free trial, there are some restrictions to send data. So I was using a load generator earlier with the same instance, and that was messing up things. But now I'm trying to use small application here. So let me just quickly take you through the application details. If I go into one of these applications, let me make it 6 hours maybe. Yeah. So here there are some tiles which will give us a detailed information, at least high level information. We can dig into this in detail. So for example, this one says P95, which is the 99th percentile. So basically 90, sorry, this is 95, yeah, 95th percentile. So there's another 99. So 95th percentile, it's a value which actually represents the point below which 95% of the data is data fault. Okay, so basically this is often used to set a realistic, upper limit. And let me show you. For example, this says 2.3 seconds here, and if you see, it came down to 817 millisecond. Okay, so most of the request, it will take, 95% of the request will take 2 seconds to get this application loaded. Similarly, we have the 99, which is a much more extreme upper limit for the performance of the values, right, which is being populated. So in this case, it shows the response time that the 99% of the requests fall under. Okay, so this helps in identifying rare and significant slowdown. Okay, and there is another part which is average. Okay, this is basically it gives a general sense of data. So it's useful for understanding overall data, but might not always reflect true performance when there are some kind of outliers. So basically, we mostly focus on 95th percentile and 99. Yeah, and coming to the duration part. So if I checked out this spike, which says 948 requests. So in last 6 hours, 948 requests we are having a response time of 750 milliseconds. So it's pretty much good. But you see here, there are some requests which took 2 seconds, and there are much faster requests also. Okay. Coming to rate, if you see here at 11 o'clock, there is a spike which says a demand in increase of request. So this will give us a request rate, which is useful to monitor the system's response time. Yeah, and coming to another tile, which gives us the downstream and databases. So basically, if you see here, there are some errors. Oh, there's one more tile here, errors, which I can explain checking at the error percentage of one of the services, which is auth service. So let's quickly click on this auth service. It will take us to data to the specific service. So there are no downstream, that's why there's no data coming up here. So the upstream is shop backend and the operations. So if you see the zero error percentage, what I can do is I can just quickly go to traces. So here I'll get the traces. For example, yeah, let me select one of the traces to just give an idea of how the traces looks like. So here from the shop backend, there's an authenticate API being called. Let me explain this. Yeah, so this is where we can get the logs for this specific issue, if there is an issue when we track the traces. Let me go one step back and show you the service map. So service map will actually show the flow of the application. So let me just go back to the shop backend and take the service map. Here we'll be able to see the upstream and downstream. So from shop backend, we have connection to article service, the auth service, and card service. And it clearly says that the downstream project, the downstream services, article service and the card service are working fine, which shows a green signal. And if you see the auth service, we have some errors. So if I click here, we'll be able to see the request rate, failed request rate, traces. I already said this is the free trial account which I created for myself. There are some limitations of getting these logs, metrics, the rate limit is there. So for now, let me just take you to the partners demo cloud account, where I can take you to the home page with a lot of dashboards. For example, if I go to the Kubernetes monitoring here you can see a lot of details related to the Kubernetes, the cluster, the number of nodes, namespace details, workloads, and the pods. So it's all the numbers here, and you can see the details of containers deployed or the image details. And then there is the CPU and memory usage ties there. If I scroll down, okay, if you see that section which says firing alert, so there's some issue with one of the services. So if I check it out, the alert is related to CPU throttle. So the CPU throttling is high. That's why the alert is getting triggered. So let's quickly check the details of this. The container is front end. This is the port name. So let me just click the port name. Yeah. So in this page, we can see the specific details related to that pod when it comes to CPU and memory. And then if I scroll down, you can see the image details just being deployed. And if you want to check the logs, let's quickly go to view logs. And here we go. You can see the pod logs. So it says the error that cannot find module for page. That is one error. Then there are other error. No, it's the same error. So let's see if there is any other error. No. So this is a major error which we can see here. This is how we can correlate the logs and the traces. So let me also go into the front-end application here. Yeah, and we have the front-end creator here. So if I go to this front-end demo dashboard here, we can see the page performance. For example, the one you can see the slash card is having some issues, and let me simply change the time to 6 hours maybe. Yeah. So in last 6 hours, see, we had issue with, we still have issue with slash card, and the checkout was having some issues. The time was most time is taking too much. Slash product API is having endpoint is having an issue. So if you want to go to that, let's click on it, and we can see the sessions here. Okay, so for example, let me just select, so this is for slash product. Let me take one of the sessions to get the details. So here we can see the user journey. Okay, so for example, let's take any one of these, maybe view products logs. See, you'll be able to see that session specific logs also in this. So in short, Grafana enables this correlation in a very good manner. This I will also like to cover the cost part. So if you go to the Kubernetes and cost here, so it's very interesting if you will be able to see the cost for the infrastructure we have built. It will also give us a saving per hour. Yeah, so the total compute cost for 30-day period, it will give a very good view of the cost part also. Yeah, and let me just go through the nodes. We'll see the cluster nodes, the CPU memory usage, then alerts if there are any. It's a very good view to get the alerts for overall environment. So this one which we already saw. Yeah, so with that, I would like to wrap up the demo. Thank you for watching, and I hope this will give you a clear view of how Grafana can streamline your observability journey. Thank you.